Okay, we're given this piecewise function and we want to make f continuous. So how can we make the function f of x continuous? What values of a and b do we need to have to make sure that where one piece stops, the next piece fills that hole so that there are no jump discontinuities? Well, in order for that to happen, we need 2x minus 1 to equal ax plus b at a very specific value of 1 for x. So when x is equal to negative x, not positive 1, negative 1. When x is equal to negative 1, let me slow down here. When x is equal to negative 1, we want the piece 2x minus 1 to equal ax plus b. I'm going to use a highlighter here. So when x is equal to negative 1, that's the value where the red piece would have an open circle, the blue piece would have a closed circle. We want that closed circle to fill in that open circle, which means they need to have the same ordered pair. They need to be in the same exact location. So when x is equal to 1, I want the red piece, 2x minus 1, to equal the blue piece, ax plus b. And I'm just going to pause there for a second. I'm not going to pause the video. I'm actually just going to pause there for a second and have you absorb that. Okay. Now, another thing that we want to happen is you can see right here, when x equals positive 1, we want the blue function to equal the green function. So we want that blue piece to equal the green piece. So again, now when x equals 1, because that's going to be another possible jump in our piecewise function, I want the blue piece, ax plus b, to equal that green piece of 7. So now I can actually do the algebra. So as long as I understand this part, all I have to do is the math now. So we're going to put that value of negative 1 in everywhere we see an x, because that's what x is going to equal. So instead of 2 times x, I'll have 2 times negative 1. 2 times negative 1 minus 1 equals a times negative 1 plus b. Well, negative 2 minus 1 is negative 3 equals negative a plus b. And I think that that's all I can do there. So that's good. Now the next one, I'm going to substitute in a 1 for x and see what I end up with. When I put a 1 in for x, I have a times 1 plus b equals 7. So that's a plus b equals 7. So now I'm in a very good position. I've got 2 variables, 2 equations. I can consider those 2 equations together. This equation on the left is the same thing as negative a plus b equals negative 3. I'm going to add this equation, negative a plus b equals negative 3, to a plus b equals 7. So I'm going to set up a system of equations. A plus b equals 7, negative a plus b equals negative 3. I'm going to add the 2 together. I get 2b equals 4, b equals 2. So this was set up perfectly for elimination. So I've got my solution for b. B is equal to 2. I'm going to plug that value back in. A plus 2 equals 7, therefore a equals 5. So my 2 values that are going to make this continuous are a equals 5 and b equals 2. And hopefully this very quick video helped you. Maybe you could watch it again, slow it down, or maybe I was going a little bit too slow. You can speed it up and get to the point that you really needed to get to. Maybe you kind of had an idea, give yourself a pat on the back, and you can search the internet for quite a few of these practice problems if you wanted to, and see how you do.